Now here in this video, we're going to look at what's called the reference angle. And the definition here we have for the reference angle is the reference angle theta prime, and we see this little mark here that's read as prime. This is theta prime is going to represent the reference angle. And the reference angle is an acute angle formed by the terminal side. Okay, it's formed by the terminal side of theta, so that's the terminal side of our angle, and the horizontal x-axis. Okay, and the other thing we need to be aware of here is the reference angle is an acute angle and it's always going to be positive. Okay, so for example here, I'm going to look at our angle, the terminal side here. I'm going to look at an example of an angle in all four quadrants. So if we start out with our angle being in the first quadrant, then that means that we would have here our terminal side is here in the first quadrant. So that means if we were to rotate, of course, we know we're always starting from the positive x-axis. So here's the angle theta. So if our angle happens to be somewhere in the first quadrant, then what is going to be our reference angle? Okay, so we're trying to find out what is this theta prime going to be? Where's the reference angle? Well, we can kind of think of drawing we can think of this as our right triangle, just like we have before. So if we draw this down to the x-axis here, we have our right triangle. And notice this angle here is going to be theta prime. Now you'll notice here, of course, in the first quadrant, for example, if our angle theta, let's say that it is 30 degrees, then basically what that means is our theta prime, the reference angle. Now what did it say? It's an acute angle formed by the terminal side of theta in the horizontal x-axis. So here is the horizontal x-axis, and the angle that's formed from the horizontal x-axis to the terminal side here is also going to be 30 degrees. So therefore, if you're in the first quadrant, your angle and reference angle will always be the same because the first quadrant always has a positive acute angle, so therefore the reference angle is going to be the exact same angle. Okay, so we can here realize that in this case that your angle theta, if you want to kind of have a formula here, theta is going to be equal to theta prime in the first quadrant. All right, if we look at the angle in the second quadrant, so that means that we would have our terminal side over here in the second quadrant. So therefore, that means our angle theta is going to be greater than 90. So we have here a larger angle. And in this case, let's just say that theta is equal to, we'll say 100 degrees to make it easy. And once again, if we think of this as drawing a triangle over here, notice now we form this acute angle over here. Again, we're coming off of this x-axis. Okay, so that's what it means when the angle comes off the horizontal x-axis here. This would be representing our theta prime. So the question is, we know that if we go all the way around, this would be 180 degrees. So here we've gone around 100 degrees, so what does that mean we have left in order for the reference angle? So hopefully with a little bit of easy math here, you can determine that theta prime must be equal to 80 degrees. Okay, and again here the formula for that would be, if you're looking for theta prime and you're in the second quadrant, then of course then that's going to be equal to 180 degrees minus, whoops, and I'll just leave this as whatever your angle theta happens to be. In our case, it would be 180 minus 100, and that's where we get the reference angle of 80 degrees. So 180 minus your angle is going to give you the reference angle if you're in the second quadrant. So I'm giving you kind of, and let me label this the other way. So theta, the reference angle, is going to be equal to whatever your angle is in the first quadrant. And then over here, your reference angle in the second would be 180 minus theta. So you can memorize this, but I think if you look at a picture, then it's just as easy to determine what your reference angle is going to be. So there's the first two quadrants. So if we look at an angle in the third quadrant, okay, so that means that our terminal side is going to be somewhere over here. And that means if our angle then is going to rotate here all the way around, this would be our angle theta. Okay, so once again, we know that all the way around to here, halfway around is going to be 180 degrees. So let's pretend here that this angle happens to be equal to, let's say, 210 degrees. So that would put us over here in the third quadrant. Well, if we think of drawing a right triangle from this terminal side here, then we can see that we would have our reference angle is going to come off of the x-axis to the terminal side. So this would be our theta prime, which is representing the reference angle. And we know that if we've gone around 180, then how much is left to get to 210? So we would certainly just take 210 minus 180. So that would tell us here then that theta prime, the reference angle, would have to be 30 degrees. And if you like formulas, then we could say that your reference angle, theta prime, is going to be equal to whatever your angle is for the third quadrant minus the 180 degrees. So this would be kind of a formula you could use. And this works for the third quadrant. Because if your angle is all the way over here, we want to subtract away, we're essentially subtracting away this part of the angle, and that's going to leave us with the reference angle. All right, the last we have is the fourth quadrant. So that means our terminal side is going to be over here, and that means if we go all the way around, that's going to give us our angle for theta. And let's keep in mind, if we do this, we know that we said here would be 180 degrees, and keep in mind if we go all the way around, that would be 360. And let's just say to keep our math easy, we'll call this angle 300 degrees, because we know once again at the bottom this would be 270 degrees. And we can draw a triangle here to help us, and if we do that, that'll help you see that your reference angle is going to come here off of the x-axis again, and we would have our reference angle theta prime. So if we're going all the way around to here is 300, so how much is left? Well, we know that if we go all the way around is 360, so that means we're going to have to take 360 degrees minus our angle of 300, and that'll tell us here that our reference angle is going to have to be equal to 60 degrees. So the formula for that would be your reference angle is going to be equal to 360 degrees minus whatever your angle is. In this case, our angle was 300, so I'm just going to put minus your angle theta. So this is the formula you would use if you want to find the reference angle if your angle is in the fourth quadrant. Now, one thing you want to be aware of, if you notice here, I was trying to use the use of a right triangle to help you to see this reference angle as well. And what I want you to notice to make sure that you always have this correctly, if I was to look at each one of these here together, if you notice when I was drawing the triangles that for the reference angle, I always tell people, think of this like a bow tie here, because when you draw this, in order to get this reference angle coming off of your x-axis, then basically that means this right triangle that we're drawing is going to have to come off of the positive, or I'm sorry, the horizontal x-axis. So what that means is your reference angle is rotating off of the x-axis. In the first quadrant, it's going up. In the second quadrant, it's going up. And then if you're in the third quadrant, it's rotating down off of the x-axis. And for the fourth quadrant, it's going to rotate down off of the x-axis. And basically what that means is when you draw a right triangle to form the reference angle, your right angle for the triangle is always going to be on the x-axis. Okay, so in other words, what I'm trying to really say here is you would never show an angle like this where the right angle is on the y-axis. This would be completely wrong, so never do that. That's why I tell you your triangle that you're using to represent here would always show kind of this. If you look at one in each quadrant, it's going to look like a bow tie. Okay, so there's the idea of your reference angle. Now I do want to look at one example here of where we can use this a little bit. For example, if we have an angle, let's say that we start with an angle in the first quadrant, and I'm going to make this pretty easy here. So we'll start with this angle here that we rotate around here. I'm going to say theta is equal to, and I'm going to use radians this time, pi over 4. Now again, we know this is, hopefully you remember, pi over 4, that would be the same thing as a 45-degree angle. Okay, and move this over here, because what we can think of is this would be our triangle here. Okay, so here your angle is pi over 4. And what we're trying to determine is if we want to find what is the sine of the angle here, pi over 4. Now we know that if we're in the first quadrant, and again this is going back to our unit circle, and hopefully you remember here that the coordinate here would be square root of 2 over 2 for the x, and also square root of 2 over 2 for the y. Okay, so this is your x and y coordinate. And we're thinking of this again as the this distance here. If it's a unit circle, we know that's going to be 1. And we can determine that the sine of pi over 4, we know that's going to be our y value, which is equal to the square root of 2 over 2. And then, of course, if we said we want to find the cosine of the angle pi over 4, once again, we know that we're here in the first quadrant. So again, that would be the x, which is square root of 2 over 2. Now, where I want to show you where we could possibly use the idea of a reference angle is looking at our next example here. All right, this time I'm going to have our angle over here in the second quadrant. And this particular angle all the way around over here, we're going to call this 3 pi over 4. Okay, now we can find the sine of 3 pi over 4. Now again, these are some angles I told you that you should know. But the idea of here where we could possibly use the reference angle as an aid is if we think about this as a reference angle, that's going to rotate up off of here. Well, if all the way around here is pi, and again as a reference here, that means this would be equal to 4 pi over 4. 4's cancel. So if this is 3 pi over 4, then what is going to be this reference angle? Well, the reference angle here would be pi over 4. And what that means, if we think of this here, if we were to find using this pi over 4, then, excuse me, we could think of what is the sine of pi over 4. And this goes back to where if you have the first quadrant memorized, we know that up here, what we just found, the sine of pi over 4 is the square root of 2 over 2. Okay, now if we think of this as a reference angle, then we know the sine of 3 pi over 4 is going to be exactly the same thing. And now what is our sine function? We know that the sine function is positive in the first quadrant. And in the second quadrant, our sine function, because that is a y value, it is also positive. So that tells us that the sine of pi over 4 and the sine of 3 pi over 4, they're both going to have the same number of square root of 2 over 2. And because these are y values, we know that both of these are going to be positive. Now, if we wanted to find, for example, the cosine of 3 pi over 4, then as our reference angle, we could think of what is the cosine of the reference angle pi over 4. Well, we found the cosine of pi over 4 above, that is square root of 2 over 2. Now, keep in mind now the cosine, we're talking about cosine is our x value, okay? And we know that if we're over here now in the second quadrant, we know that our x coordinate is going to be negative. So that means our cosine function, which is the x, our cosine function, remember in the previous video we talked about our cosine function being x in the second quadrant. That means it's going to have a negative sign. So that tells us then that the 3 pi over 4, we're going to have the same number square root of 2 over 2, but because this is now in the second quadrant, it tells us that instead of a positive, it's going to be equal to a negative square root of 2 over 2. So that's just kind of one example of how we can relate to using this reference angle and evaluating our trig functions. Now, of course, we don't necessarily have to use that because we know that if we were to specifically look at this point, and again, if you look on the unit circle, what we know is this point is negative square root of 2 over 2, and the y value is a positive square root of 2 over 2. So again, that's kind of the connection that we're making with this point in the second quadrant for the angle of reference here, pi over 4 and 3 pi over 4, to this one up here. If you notice here that your x and y numbers are the same, the only difference is that the x coordinate is negative because we're in the second quadrant at the one at the bottom, and the x at the top, because it's in the first quadrant, is positive. So that's kind of showing you how this idea of reference angle will work to help you with possibly finding the uh, value of a particular trig function. Okay, so once again, reference angle, a couple things to remember is it's an acute angle formed by the terminal side of theta and the horizontal and x-axis. So it's always off of the horizontal x-axis. It's an acute angle, so it's less than 90 degrees. And also remember, it is always a positive angle. The reference angle is never negative.